use the quadratic formula. That's a mean squared angle. That's a mean squared angle.
What was it?
ABC. Wait, yeah. And ABC.
How is this not? ABP.
Yeah.
What's
I'll tell you
this?
later.
What did you get?
So, remember at the end, if you're going to factor or use the quadratic formula is the thing with the song, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. Remember, the quadratic formula is used when you have a trinomial, ax squared plus or minus bx plus or minus c. The a, the b, and the c are either coefficients or constants. And then you would just stick those numbers into your problems. Or you can factor it. But you sometimes can't factor some things. You can always use the quadratic formula. Okay? So that's going to come into play at the end today, when you get to some of the problems that you can work on. Today we're going to still look at secants. Yesterday, or 2 days ago, we introduced secants. And secants were what?
They basically intersected at 2 points.
They intersect at 2 points. So we could have a secant that acts as a line, right, that extends in, or we could just have secants that are chords. And today, mostly we're going to look at them as chords. All right? So again, remember when we're talking about a chord starts on one side of the circle and goes and has an endpoint on both sides of the circle. That's a chord, right? So today we're looking at the intersection of two secants. So instead of having secants where there are lines and going through the circle and ended up crossing either on the outside like we had the other day, now they're going to be kind of something like this. Okay? So the first one talks about, 2 days ago we were talking about having secants and doing angles and arcs, right? Today we're going to talk about the lengths of the chords. So the actual measurements of the actual segments instead of the angles or the arcs. Okay? So this leads us to our first theorem. 10:15, huh? So again, if you want the words say if two chords intersect in a circle, right? That's what we just drew. Then the products of the measures of the segments of the chords are equal. What's that mean? What's the products?
Getting a line.
What's the product?
Multiplication.
Multiplication, right? So let's name this. What do you want to name it?
J's.
J's again?
Yes.
So it says, 10:5 says, two secants intersect. The measure of the chords, okay, or the segments, is the products of the chords. So here, right here, A, oh, I need one in the middle. W for chords, right? So AW times, we said as a product, right? WS is equal to, then the other side, JW times WY. They're just equal to each other. Okay? And, well, you really don't need the bars, but I just want to show that they are the segments, not the arcs. So some people yesterday had some confusion with arcs and angles and the symbols. So just be careful that you got the right symbol here. We're talking about the segments. Okay? Everybody okay with that? Pretty self-explanatory. So they'll start giving you some numbers here and you just plug it in. Okay? You just plug in the numbers for the parts, or this is where you might have quantities instead of just numbers. Quantities just meaning that we have something with a variable. Okay? Everybody good with that? All right. Gabriel, any questions so far?
No.
All right. I know. Thank you. So the next thing that we're going to talk about, so this is our first one. The next thing that they talk about in this is if I drew a circle again, and now I had a secant, but I had a secant that was like on the outside of my circle. And I still just had it as a segment. Okay? And then I had another one starting here, and I went this way. Okay? Everybody agree that these both are still secants? Right? Because this segment only touches my circle in two spots. This spot up here and this spot down here. Or this spot and this spot for the second one. Okay, so what we want to emphasize in this is this part right here. This is called the external part of your secant. So basically it's the part on the outside of the circle. Bless you. And this is going to be important for the next couple of things that we talk about. So you're going to talk about the external part. That's important. All right? Which leads us to Theorem 1016. So again, all we're doing is trying to find different ways of finding parts of the actual secant today. Now again, lots of words in this one. If a secant intersect at the exterior of the circle, okay, so we just did that. They met at the exterior of the circle. They meet at the exterior of the circle. We come back here and we start naming it. M, N, O, P, and Q. Okay? Then the product of the measure of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant. Right? What the heck? Okay, so maybe that makes sense to you, maybe it doesn't. But basically, to kind of put it in our own words, or put it into words that make sense to me, I'm going to take the entire secant times the external part. And then I'm going to set it equal to, and then I'm going to do it the same thing, the entire secant. So this makes more sense to me, or so if we look at our figure here, then we would say what? How do I compare these? I'm going to do the entire secant, which is what? OM. And I'm going to multiply that by just the outside part, but of the same one. So now we're going to multiply it by ON. And we're going to set that equal to, now we're going to do the other one. So the entire of the other one is OQ, and we're going to multiply that one by OB. Okay? So this right here says the exact same thing as that does. I'm just trying to hopefully make it easier for you. If you want all of the actual words, again, you can either copy it from here or it's in the book. So again, just different ways of again, finding portions of particular secants. Okay? And then in 1017, now we're going to basically do the same thing, but now we're going to have a secant and a tangent. So again, what's a tangent? It only touches in one spot. So can you draw that picture? Draw a picture where a secant intersects a tangent on the outside of the circle. A secant intersects a tangent one time on the outside of the circle. Can you do that?
Yes.
Where'd you put your point?
Like down to the left a little bit.
Down to the left, okay.
Yep. And put the tangent going up.
Okay, my tangent goes up.
And then the secant goes through the circle.
Perfect.
Other side.
Okay, so this is my figure. So now, what do you think we're going to do if I'm going to tell you it's basically the exact same thing as this one. So instead of having two secants though, where we're multiplying, now we only have one piece in this one, right? There's only one little part. So what do you think we do with that one little part? We take it times itself, right? So what are we going to name this? JKL what? M. Okay? So basically this says the same thing that this one says. So if you want to write it out, our entire secant times, again, the external part. And we're going to set that equal to, now if we do the same thing with this, we only have one part, right? So we have to take the tangent times itself. So in the book, I believe they just say that you would take LM and square it. All right, so we're going to do what? What's the whole secant? JL times KL, always the outside part, is equal to, then we'd say LM, and we're going to square that. So notice this is probably a lot of the time where you're going to end up with something that you could put into this. So again, when you end up having to either factor something or put it into quadratic formula, how many answers do you get?
2.
2, right? That's why this says plus or minus. Okay? But if you're going to factor it, everybody understand what we mean by factoring? Making your 2 sets of parentheses and then trying to find the factors? I personally would always try to do that because it's just faster. But again, some of you didn't like factoring the first time. Okay? So you might not like that version of it. You can always do the quadratic formula. Okay? You just have to remember how to do the math. And we'll show you all that in a second. Okay? We did 17. And then we just explain that. Okay? So 1016 is this one. And then 1017 is this one. Okay? Questions here? With the words. So hopefully we can find a couple that have, or show you some factoring and stuff. Alright, so this changes to our first version. So we're back over to 1015, where we have 2 secants that cross in the middle. Alright? So what's the math going to be here? So this is where you kind of got to shift it a little bit, right? This one you're taking all the pieces and just multiplying them, and then you switch to the other two, and that's where a lot of people just say, well, I'm going to take this one times this one. But it's the whole thing times the outside. So that's where you kind of got to switch gears and understand which one you're looking at. So again, if it crosses on the inside, you're just multiplying the pieces times each other. If you're crossing on the outside, then you have to do the special one where it's the whole thing to the outside. So this one we would do what? 12 times 9 equals 8x, right? And then how do I get x?
Divide by 8.
Divide by 8. So what do we get? Really? Way to go, Gabriel. Good job, buddy. All right. So, now we get a little more complicated maybe, right? So again, don't freak out about this. If I have 2 quantities, what do we mean by a quantity?
Variable.
Just has something with a variable, right? If I have a quantity times it's another quantity, what do I have to do if I'm going to do multiplication to it?
Foil.
I'm going to do FOIL. Or in the other one, when I'm doing P to R, then I'm just going to take that X and what? Distribute it. Okay? I got to distribute it. So let's look at the math for this one, right? If I do X plus 4, I'm going to multiply that by what? X plus 2. And I'm going to set it equals to X times X plus 10. Okay? So again, don't just jump to the conclusion that if I do it this way, I'm automatically going to have to factor. Because this one actually turns out pretty good, right? Because when I do FOIL here, what do we get?
X squared. Plus
16x.
No, plus
Plus 8, right?
Oh, it's minus 12.
Remember, first, outside, inside, last.
Oh,
Everybody
it's
good with all
2x
that?
plus 12.
Okay, again, this is what I always did with when I did algebra. I don't know if this helps, but if you're confused with it, you can always put those letters, and those letters will always be in the same spots. And then I'm just multiplying the letters together. So F times F, and then my O's and my I's should always be like terms, right? So they should be the same thing that I can combine. And that's how we got 6x here, right? 4x plus 2x. Okay? Over here, I'm just distributing, right? Remember what's distributing? I'm taking it times everything on the inside. But notice here, when I want to combine like terms, my x squareds actually cancel each other out in this one. That's why it's really not that bad. So then I'm always going to take my x towards which one? Usually the bigger one. Why?
Negative.
Then we avoid the negatives. Now you don't have to, but then you might end up with negatives and it gets some people confused. So minus 6x, we get 8 is equal to 4x, so x is 2. Then you got to make sure that you what? Answer the question, right? In this case, they just asked to find x. Okay? Questions with that? So again, don't freak out just because you have to do FOIL. FOIL is really not that bad. And I don't think they show you one. I'm going to come back to that one at the end. So here's the next version of it. Okay? So now we're moving over to 1016 or 1017. And they usually go straight in order. So now we should have two secants, right? So again, the most important part of this is that you remember the first one, yes, we did the top times the bottom and the left times the right. But when we switch to, when it crosses to the outside, you got to make sure that you always do the whole thing times the outside. And that's where a lot of people forget. So in this one right here, I'll try to write it up here so we don't go back and forth. What are we going to write for this one?
X plus 8.
8x.
Alright, so, say it one more time.
X plus 8 times 8.
X plus 8, because why, Gabriel?
It's just the whole thing.
Because it's the whole thing. And then we're going to take that times, what? The outside, right? Everybody good with that? So the whole thing is taking 8 plus x is equals to, what's the whole thing on the other one? 34 times 10. Everybody good with that? Everybody understand where we got all those numbers?
So why do you put 8 in the front then?
Because I'm doing the outside times the whole thing.
Oh.
So the whole thing is me taking x plus 8. So down here, we could actually take 10 plus 24. That's how we took these two and added them together, and that's where that 34 came from.
Okay.
But I can't really do that with a variable and a number. Okay? So what do I do on the left-hand side?
Distribute.
So what do I get?
8x plus 64.
8x plus 64 is equal to
340.
340. Now you should be able to do the math, right? Okay?
Just go for it, Diesel.
So what are we doing? Subtracting 64 and divided by 8. Okay? And then, again, they only ask you to find x, but make sure you answer the question. Go ahead.
EF and EH supposed to be congruent?
No.
This is live.
That was when it was a tangent. Okay? So good question. Everybody hear what he said? He said, aren't EH and EF supposed to be congruent? That was when we had tangents from the same spot hitting back to it. So that's a good thought process, but we're not at that. Good thinking though, Gabriel. Next one looks like it's so. We got to get to a factoring one sooner. Ooh, maybe this one. This one should be a factoring one. Okay? So what are we going to do here? So again, remember, the outside portion times the whole thing. So the outside portion is x. The whole thing is what? X plus 2. Everybody agree? Is equal to what?
2x squared plus
12 squared.
12 squared, right? So again, now we're to this one, right? My outside of the secant times the whole thing is equal to the tangent squared. So again, we're not going to factor, aren't we? On the inside, what do I get when I take x plus x?
2x.
So I'm going to have x times 2x plus 2, right? Again, I can't take x's and add them to 2's. So now I'm going to distribute, and I get what?
2x squared.
Plus
2x.
2x is equal to? Ooh, we are going to be able to. So now I'm going to bring everything to one side. If I bring everything to one side, I'm always going to bring it towards which one?
Variable.
To the x squared part. I always want to take it and make my biggest variable positive. So in this case, x squared. So you can actually try to factor this right here. But if you look at every single term, what do you notice?
2.
There's a 2 and everything, so the first thing that I'm going to do, I'm going to take that out. Now remember, what's 144 divided by 2?
72.
72. Okay? So, those of you that need a refresher on factoring, what happens to this 2 out in front? Anytime that you have factoring, you can take the number out in front and set it equal to 0. Can 2 ever equal 0? No. So you cross that 2 out. It's just kind of gone. Now I'm ready to factor this, right? X squared plus x minus 72. Remember, 2 sets of parentheses. X and x. How do I know what my signs are?
Plus and minus.
Plus and minus because why?
There's a negative.
No.
There's a
So
negative.
it's not plus and minus because there's one of each. It's plus and minus because if this second sign right here is negative, then these are opposite, or one of each. If this sign right here is positive, these 2 signs are the same, and they're the same as this sign right here. Okay, so we do have plus and minus. If I have different signs, what do I do with like terms? Add or subtract them? If I have -4 plus 3, I actually do what with those numbers? Subtract them, right?
Yeah.
One positive and one negative. If I'm adding, I'm actually going to subtract. So, what are the factors of 72
9.
that subtract and give me 1?
9 and 8.
9 and 8. And which one has to be positive?
9 because your x is positive.
Always the bigger one, right? The bigger one has to match the sign of this one right here. So I get plus 9 and minus 8. So now, what are my answers though?
8 negative 9.
Positive 8.
Because why?
They're equal to 0.
You take each one of those and set them equal to 0. So x is equal to -9 and x is equal to 8. I would tell you that 95% of the time, if you get a negative answer, you can do what to it? Throw it out. Okay? It probably is not going to work for a problem like this. Does it really make sense that LK is a negative distance?
That's what I was wondering.
No. So, in all honesty, I'm throwing this one out, and 8 should be my answer.
Why, when you get the x squared plus x minus 72,
Where are we at?
at the very top,
Yes?
yeah, why couldn't you just do 2x squared
2.
minus 72?
Because this is, well, this right here and this right here aren't the same thing. They're like cousins, okay? You want them to be the exact same thing,
yeah.
okay? Now, if you don't like this right here, we come back to this right here, and we're going to stick it into this formula right here. So if you want to see what the quadratic formula is, this is A, this is B, and this is C right there. So negative B would be -1 plus or minus the square root of. B is 1 again, squared. -4 times A. A is 1. It's the coefficients, right? Times C, which is what?
Negative 72.
Don't forget the sign. And then it's all over 2 times A, but A is 1. And then I would simplify.
Can you still use it with the 2s as your coefficients?
Yes, or you could go all the way back here and do it with this. You would just have to, no, in this, it's not gonna matter. Yes, so you could go back to this one. So then I just simplified, -1 plus or minus the square root of, what's -4 times -72, and you add it to 1 and then take the square root of that. So that's just a different version of it. You can always do the quadratic formula with every single problem. You might not always be able to factor it. Okay? So that's where quadratic formula comes into play. Okay. Questions here?
8.5.
So again, I would really look over, especially if you don't like to factor, there are a few on the homework that you will have to factor. Okay? And again, then make sure that you come in and see me if you need some help. If you try to do the homework, the one with the guy next to the tree, it kind of explains it right here in these directions. So if you're going to do number 22, make sure that you understand that the little guy isn't equal to the tree. You'll understand when you get there.
About my question.
Oh yeah.
What's the